Good morning, everyone.
Good morning, sir.
Good morning, sir.
Yes, I have forwarded the data set to you. Can you share it with the others?
Yes, sir. I have shared with them. I think they might have got it.
Okay.
Sir,
Yes.
today only 2 hour session.
Today what?
Only 2 hour session.
Today?
9 to 11 they can be provided in our email.
I did not get that mail. Sorry. Can you share the screen and show me? What is it? Is it not 9 to 1?
No, sir. That is एक second.
Okay. Anyway, we will continue. If it gets disconnected or if someone says that you have to log off, then we will disconnect. Otherwise, we'll continue. So should we start or should we wait for the others to join? I guess we can wait for a few minutes, let others join, maybe 5 minutes or so, and then we can start. Okay, I guess we can start. Have you all got the files?
Yes.
Okay. Can you please confirm if it is still 11 o'clock or 1 o'clock, or is it?
So the meeting invitation mail said 9 to 11 a.m.
9 to 11 a.m. Okay. Okay.
Actually, it's copied from previous mail. Hello?
Yes.
Actually, the mail was copied from previous mail, that is from Sunday when soft skill was there.
Okay.
Only the date was changed and timing was same. That's the mistake they made.
Okay. Okay. Okay, fine. Okay, is my screen visible?
Yes, sir.
Okay. So the logistic regression algorithm, what we saw last week, is used mainly when we have a binary classification. So binary classification means when we have a dependent variable which is of type class. Okay, so class means I have to predict whether it is going to be 0 or a 1, true or a false, yes or a no. So in this case, I have the y variable as churn, which is having a value 1, which means the customer has churned. 0 means the customer is not churned. Now, this particular data set, so what do you mean by the term churn? What does it mean? Now, let's say that you are a customer with a bank, or whether you are a customer at, let us say, a company that provides you services. For example, mobile service or telephone service or DTH service. Okay. So you are a customer here. So let us take, for example, you are with, let's say, Airtel. Now, as a customer, you have been there for some time. You have taken their products and services. Now you decide to leave Airtel and switch to some other company. Let's say Reliance Jio, for example. Okay, so this switching of companies from one to other is called churning. Now, why is churning such a big deal? Is because customers, when they leave the company and they want to go to a different company, it is a loss for the organization. Okay, so it is a loss for Airtel because they don't want to lose customers. So when they lose customers, obviously their profit margin will reduce. A lot of other things can also happen, but they don't want to lose customers. So one of the analytics that they implement in-house is the churn, or we can say customer churn. So they want to find out what is the likelihood that a given customer will churn. So if they detect any pattern that they are likely to churn, they will do everything in their capacity to retain that customer so that they can provide that customer more services, better services, or if they have anything pending in terms of any open tickets or whatever issues they have, they will try to resolve it. So this is the whole idea behind implementing the customer churn. So as you can see from the data set, churn is a binary classification. So yes means the customer has churned. and no means the customer has not churned. So this is the historical data. So what are the factors that affect churning? So there could be multiple factors. There could be one factor. There could be n factors. So what are those factors that affect customer churn? So here I have a few features like the surname of the customer, credit score, the country, gender, age, tenure, the bank balance, status, salary, and then the Y variable, which is churn. Now, are these all significant features? How do you do the feature selection? So that is what we are going to see, and then build a model using these features and find out how good my model is to predict the customer churn, which is indicated as 1. So 1 is my positive class, which is for churn, and 0 is the negative class, which is no churn. Okay. Any questions on the...
Sir, your churn is they have changed the bank or they are likely to change the bank? 1 means.
So 1 means they have already left the bank.
Okay.
And 0 means the customer is still with the bank. So this means already churned. And 0 means not churned. Clear?
Yes.
Now you will see some slight differences in the data set, what we saw in the linear regression and what we have in the logistic regression. Now there are a couple of differences. There are two main things that you will see. Number one is the Y variable. So in the linear regression, the Y variable was a continuous number, whereas in the Y variable of logistic regression, it is a class. Even though it is represented as a number, but this is actually a class. The second one is with respect to the features. Now look at the features. It is a combination of strings, then combination of classes and numbers. Okay, so I have strings, I have classes. Instead of classes, let me write this as categories. And then I have numbers. Now tell me, before we get started, whenever you have a combination of these things, how do you know which features to keep, which ones? How do you treat the data when you have a combination of all these things?
Convert the categorical variables into dummy variables.
Okay, convert the categories get converted to dummies. Very good. Fine. What about the numeric data? Numeric data remains as it is, isn't it? There is nothing to do in that. Now, what about the string data? How will you treat a string data?
It can be set in a pattern of ones and zeros.
Ones and zeros, okay. How do you convert it into ones and zeros?
That I don't know. I've just learned theoretical.
So usually whenever you have a string data, now what do you mean? What is the difference between a string data and a categorical data? Now in this example, if I say surname is a string data and country is a categorical data. Now, if you look at it, both are strings. Surname is also string, country is also string, but I'm specifically saying that surname is a data type string, but country is a data type string, but it is a categorical data. So what is the difference between these two?
Sir, surname has a broad spectrum, whereas country will have only certain amount of categories like France, Spain, or Germany. Not more than that.
Okay, correct. So the difference is categories are limited. They have only limited values, and the entire data set is distributed within those categories. So for example, if I have 1,000 records and there are only 3 countries, so the 1,000 gets split into the 3 countries. So this could be 500, this could be 300, whereas this could be 200. Okay, so the name of the countries are limited. Whereas if you look at the names are unique. I mean, there could be instances where 2 names are same, but the names are unique. So I cannot consider that to be as a categorical data. It is a string data. So whenever I have a string data in my data set, I should always drop it from my data set, because this cannot be used to build a model. Whether it is linear regression or logistic regression or any algorithm for that matter, this is used only for analysis, but model building, this will not work. Okay, so I have to drop the string data. So here I'll write drop the feature. Clear? Okay, so here we have the string data as surname. So we are going to drop it. So any other column that you think needs to be dropped? Yes, anything else?
Sir.
Yes. Is there any other column? If you do a quick analysis, we have seen that surname can be dropped. Is there any other column that you feel should not be or cannot be part of my model? Customer ID, okay. So you have to analyze it like this. Is customer ID related to churn? So all even number customer IDs will have churn, odd numbers customer ID will not have churn. Can I do this kind of a interpretation? Answer is no. So customer ID has no relevance to predict churn. So I can also remove customer ID from my data set. Okay, other things, credit score, country. So this is a numeric data. This is category. This is numeric, and this is my Y variable. So we will see, we'll build the model with this and then see the performance. And based on that, we will do some alteration on the model so that we get a good prediction. Okay, clear? Any questions on the data? Okay, fine. So now open the spider application or Jupyter, whichever one you're comfortable with, and then we can start. So please confirm if we all have got the file, the CSV file. So we'll start with importing the libraries. So import pandas as PD. That's the first one. Now I'm going to import a library called as unique. I'll tell you why I need that. So from NumPy, so this is to analyze my categorical data to find out what are the unique values. And in case if there are any duplicates or bad values, I can reduce the number of levels. So train test split is to split the data into training and testing. Statsmodels.api contains the logistic regression model. So there are two models which are available. One is called as the logistic model, logistic regression. I think you probably are aware of that model. And the other one is called as the logit model, L-O-G-I-T. So we are going to use the logit model. So just like the OLS model, I can also get a summary of this particular model. Then from sklearn dot metrics. So after I build the model, I have to evaluate. So evaluation technique, I have three main things. One is the confusion matrix. The other is accuracy score. So I'm going to put the accuracy score first. Now confusion matrix, I'm not going to use the inbuilt method because it is not very convenient to read it. So I'm going to use the pandas method for plotting the confusion matrix. Now the third one that I have to print is called as the classification report. Okay, and what else do we need? We need feature selection. So from sklearn dot feature selection, import f underscore classif as feature selection. Okay, so we'll have this for now. If I need anything else, then we'll import it later on. So next thing is we will read the file. So I'm going to first set the path. So file name equals. So I'm just going to copy paste the path here. And then use churn equals pd.read underscore CSV file name. Then you can just print out the data just to check if everything is fine. So churn.head, just print the first 3 records. So you can see that everything looks good. Okay, have you finished till this point? Have you all finished? Please respond, please. Otherwise, I don't know whether you're working or not. You can take. Okay. Fine. Okay, so you can do some basic analysis like churn.head shape, size, then what are the columns available. Now, the first thing that we need to do is remove the columns that we don't want. That are not required. So we have already identified those features, customer ID and surname. So we'll remove those things from our data set. So churn.drop. Columns equals customer ID and surname. And then we will write in place equals true. Now just check the columns here. So churn.columns, you will see that the 2 columns have been removed from the data. Okay, now the next thing that we want to do is the analysis of the data based on the data types. Now, if you look at the data types, so churn dot D types. So here we have a combination of numbers and object. Now, object can be treated as both strings or it can be treated as categories. Now, since we know that country is a category, gender is a category, so the object is a category. So we cannot use the same concept of analysis for the entire data set. So we need to split the data according to the data types and then carry out the analysis for the numeric data separate and for the object data separate. Now, can anyone tell me what are the different types of analysis you would perform on a categorical data?
One category is fixed, and other two category can be referred as the fixed one.
Sorry, what was the analysis you said?
I have not the name.
Yeah, go ahead, please. What was it?
Yes, sir.
What kind of analysis you will perform on a categorical data? Okay, what is common analysis that you will do for both the category and the numeric data? Do you think we have anything in common, that any test that we can do for the entire data set? Hello?
Sir, in gender, we will convert to 1 and 0.
That we will do later. I'm just asking you, before we do that, we have to carry out the analysis on how the data is structured, distribution, etc., etc.
Sir, null value variables.
Null. Okay, so check for nulls. Okay, so the null check is going to be common for both the numeric as well as for the categorical data. Now, what are the specific things which are applicable only for numeric data? And what are the specific things which are applicable only for categorical data? So nulls we can say on the entire data set. Okay, so you can do that. Churn dot is null dot sum. Okay, now this is going to give you the count of how many records have nulls. So here we can see there are no nulls. Okay, so this is fine. So now let us analysis on the data types based on data types. Okay, so I'll have two sets of features. One is the numeric columns. So how do you extract the numeric data? So first of all, I have to get the numeric columns, and based on the numeric columns, I can extract the numeric data. So the function is churn dot select underscore d types. Now I want to extract all the numeric data. So if you look at this output here, the numeric data can be int 64, float 64. So that means I need all the numeric data. So from the select data types, I can either include the int 64 and float 64 so that I can get all the columns which have these two. So I'll include them, or I will exclude all the objects. So that will give me all integers and floats. Okay, so both are right. So here I will write from the data types, exclude all the object. And then columns dot values. Now, if you print the value of NC, which is numeric columns, you will see that it will return the columns credit score, age, tenure, balance, active, and salary. Okay. Similarly, for the factor columns or categorical columns, I will do churn dot select underscore d types.
Sir, in the output there is d type is equal to object. What does it signify?
That is the output of the numeric column. We are not worried about that one.
Okay.
We are only getting the names of the columns here.
Okay, sir.
Now for the factor columns or for the categorical columns, I'll put CC so that you will know their categorical columns.
I got you.
Sorry?
Sorry, sir. Nothing.
So for the categorical columns, I have to include the object. And then I'll give columns dot values. Now, if you print CC, you will get the value as country and gender. Okay. Now for the numeric EDA, we have already done the numeric EDA. If you look at the linear regression. Okay, this is the linear regression code. So we have already done all these checks. Okay, plot charts. So you can copy this code here and carry out the numeric EDA, that is plotting the chart, histograms, and all that. Okay, I'll tell you how to extract the data. So how do you get all the numeric data? So churn within brackets NC. So this will return all the numeric data here. So look at this: credit score, age, tenure, balance, active, salary, and churn. Okay. So if I do the mean, I'll get the average credit score, average age, average tenure, average balance, average salary, etc., etc. So I'll just make a note here for the numeric EDA. copy the code from linear regression. To get the numeric data from the data set. You use the function churn, that is the data set, and within brackets, NC, which is a numeric column, will return all the numeric records. Okay, so this code you can include. Now we'll see how to analyze the factor columns or the categorical data. What are the different things that needs to be analyzed in a categorical data? Yes, anyone? How will you carry out the analysis for a categorical data? What are the things you will look for? Yes, Ankita, Kamlesh, Tejas, Yash. Am I audible to everyone?
Yes, sir.
Anyway, so I'll just continue. So you will check for unique values. And if you don't have unique values, you will convert the data into unique values and reduce the levels. Okay, so for every categorical column in CC. Right. Categorical data equals plus C and print the unique values as churn of C dot unique. One second. Country. Just print out this churn of C dot unique. Okay, so there you go. So I have a categorical data. And the unique values are France, Spain, Español, Spain, Germany, Germany, France, Fra. And for gender, the unique values are female, F, M, male, female, and M. So do we need to make any changes to the data, or are these levels right? Hello? Are these levels correct, or is this not right?
Not right, sir.
Okay, Kamlesh says it is right for the gender. So why do you think this is not right? What is not right in these values?
Sir, it has two variables for female. For example, entire word female and F, both are different for it. And as well as the uppercase and lowercase also. And in country, the Germany spelling, the uppercase, lowercase, as well as the short form also. So it creates 6 different categorical variables, unique variables.
So what should be done so that we don't have this kind of a category?
Replace it with unique.
Yes, correct. So we need to replace all these things with a single value of our choice so that we can reduce the number of levels. Okay. So next we will see how to reduce the levels for each category. Now let's start with the first one. So look at the category called country. So we have churn dot country dot unique, churn dot country. Now, what is it that we want to replace? We want to replace every occurrence of France in small case, every occurrence of small, which is spelled FRA. We want to replace them with this term, which is France, where F is capital. Okay, now you can decide how do you want to rename or how do you want to have the levels. If you want to have the country name as F, S, and G, that is also fine. So that choice is yours. So here we'll replace all occurrences of France with France. Okay, so we'll replace all occurrences of France with France in capital letters. So there are multiple ways in which we can do this. So the easiest technique is there is a function called replace. So churn.country.replace. So what are the values that I want to replace? And with what value I want to replace? So here, if you notice the spelling of France, I have small case France and then capital F-R-A. Now I want to replace both these strings with the term France in uppercase F and then use in place equals true. So this will update all the occurrences into the term France with uppercase F. Is this code clear? So same thing, you can do it for Germany also. So I'll just copy paste this. And here you can see Germany, the spellings are G-E-R. Then there is G-E-R-M-A-N-Y, all in small case. So this you can replace with Germany. And then replace all the occurrences of Spain in small case or mixed case with the text Spain that has the capital S. So here, if you look at the values, it is Español, which is the Spanish spelling. Then Spain in small case. And this has to be replaced with this. So now let's execute each one of them. Okay, so now let's run this for loop again and see. So now you can see categorical data country, the values are France, Spain, and Germany. Whereas the gender is still having the issue that it has not been replaced. So now we can reduce the levels for gender. So churn dot gender dot replace. And then copy paste it for the male also. This is M. Now run the for loop. And now you will see that I have the categories as male and female. Finished? Any questions or doubts?
Sir, we will take for the graph selection plot charts, we have to select the features. So your features will be the numeric column, right?
Features will be the column names. So churn dot columns. These are your features.
Sir, so we won't be taking country and gender from it, right?
Country and gender are also features, isn't it?
Okay. Yes, sir. Yes, I got it.
We have only changed the values of country and gender, not the column as such.
Okay, sir. Got it.
Now we will be changing the values into one hot encoding because now they are in the string format. That now we will do that. Any questions from anyone? What we have done so far with the categorical data? Is this clear why we are doing this? Okay. Now, one of the issues that we can have in a classification problem is the problem of imbalance. Okay, where the distribution of the positive class and the negative class, it need not always be 1:1 or 1:2 or 2:3. It can have a lot of imbalance because that is how the real life is. So that may actually not give us a very good prediction when we do the test data or the unseen data. So it is good to understand how the distribution is. So we will find out the distribution of the classes to check imbalance. So I have not included this here. So you can write import matplotlib dot pyplot as plt and import seaborn as SNS. So there is a plot called as count plot. So count plot is going to return the distribution of the y variable, and it is going to show graphically how the distribution is. So here x equals churn. That is what I want to find. So what is the data? Data is also churn. Okay, so now if you look at the output, you can actually put plt dot title churn distribution. So here you can see that the churn distribution of the positive and the negative class. So I told you that 1 is the positive class, that is how many people have already left the bank, and 0 is the negative class, that is how many people are still with the bank. So since I'm considering the churn to be the positive class, you can see the imbalance in this case. So this is my positive class of churn, and this is the negative class, which is no churn. Now, can you guess what is this, first of all, is this balanced or imbalanced or highly imbalanced?
Highly imbalanced.
It is highly imbalanced. If you look at the count, this is roughly how much? 8,000. And this is roughly 2,000. So the ratio of positive and negative class is approximately 1:4. Okay, now keeping this in mind, we have to build the model in such a way that I want the maximum predictions or good accuracy for the positive class also and for the negative also. That is, all the churns should be correctly predicted as churn, and all the no churn should also be predicted as no churn. So if both these measures are giving me good results, so this is measured as recall. So this is recall for the negative class. This is recall for the positive class. Then combine these two with accuracy plus area under the curve score. So this will give me a good result. Okay, so let's see that given this imbalance or high imbalance, am I able to get a good accuracy or not? Is this clear? Okay. So you can do the other analysis. I have already given the code in the linear regression topic. So you can copy paste that and find out the distribution and the heat map, all those things you can do. Now the next thing that we'll do is convert the categorical data into dummies. What is the formula for dummy variables? if I have n values in a given categorical data, how many dummy variables should be created? Hello? So dummy variables is n minus 1. So there is a function called to underscore dummies. Get underscore dummies. Now for which column you want to get the dummies? So I have to get it for, let's say, country. So I'll do churn.country and I'll just print out the first 10 records. So here you will see that I'm getting the dummy variables for the first 10 records. Okay, so first country is France. So we'll see France. So we'll see France as 1, Germany and Spain as 0. You look at the second record. Spain is 1, country Germany and country France is 0. So this is how the one-hot encoding will be done. Okay, but this is not the right technique to do it because the formula for dummy variables is it should be n minus 1. But here we are getting all the n. Okay, so this might cause multicollinearity in your data set. So we should take only n minus 1 into our data. So how do we convert this into an n minus 1? So in the get dummies, you can either do it manually or you can use the inbuilt function of the get dummies method. So here I have a parameter called drop underscore first. So drop first means the first column of this output will be removed and you will get n minus 1 in your data. So if I use drop first equals true and now see the difference in the two output. So you will see that France column gets dropped. So now I have Germany and Spain. So the first record 0, 0. So what is the meaning of 0 and 0 of the first record? So Germany is 0, Spain is 0. It means the country is France. 0, 1 means Spain, 1, 0 means Germany. So now this is converted into a dummy variable. Now where is France? So since France is missing, France is known as, what is the name of this column where the value is missing? It is called, I told you last week. This is called as the reference class. Okay, so let's do the dummy conversion. So first is create a copy of the data set. So I'll do churn underscore copy equals churn dot copy. is always recommended to do this changes on the copy. Do not use the same data. Otherwise, in case if you want to revert, you have to do all these steps again. Now create dummy variables on the categorical data. So for every categorical data in CC, so we have already created the CC here, categorical columns. So dummies equals pd dot get dummies. For which column? It is going to be for churn of C. And then drop underscore first equals true. And then new so churn copy equals churn underscore copy dot append, sorry, not append, join. Dummies. Just reduce the, just make this dummy. Okay, and let's run this. And now if you look at the column names, churn underscore copy dot columns. Okay, I forgot to do one thing here. Here it should be prefix. Prefix equals C. Okay, now, so the meaning of prefix is it is going to add the column name as the prefix and then followed by the name of the value of the categorical data. So here it was Germany and Spain. So here it says country Germany, country Spain, and gender male. So now this becomes more easy to read. So now my data is converted into a dummy. Now, if you look at the columns, you will see that I have the country also present, and I also have the country Germany and country Spain also present. So there is a duplication of record. Okay, so you see country here, and I also see country Germany and country Spain, both are present. So now I need to get rid of this and this. Okay, so from the churn copy, I have to drop columns equals CC and then in place equals 2. Now if I use churn underscore copy dot columns, now you will see my data is credit score, age, tenure, balance, active, salary, churn, then country Germany, country Spain, and gender underscore male. And if I do churn copy dot head now you can see country Germany, Spain, and gender male. So I have got my data into a numeric format. Is this clear to everyone?
So repeat again. Create dummy variable on the category variable.
You understand the dummy variables creation? Okay, let me just explain this part, then we'll take a break. See, you have a column, let's say country, okay? Now this country column has three values: France, Spain, and Germany. Now I cannot have strings in my data because strings won't fit into the formula. So this needs to be converted into numbers. So how do you convert a string into a number when you have a categorical data? So this is done using one-hot encoding. Okay, also known as dummy variables. Now, when I use the dummy variables, the formula is if there are n values, so here n equals 3, the number of dummy variables will be n minus 1. So n minus 1 means I can take any two to be the dummy variable. The remaining value is going to be known as the reference class. So in Python, there is a function called getDummies. So getDummies will take a parameter, which column you want. So if I give country column here, it is going to make the dummies for the country column. Now, because the formula is n minus 1, so by default, it is going to return all the three values, but I want only 2 according to the formula n minus 1. So there is a parameter called drop first. So if I give the drop first parameter as true, it is going to drop the first column and return the remaining 2 columns. So now this fits into my formula. And then prefix equals C means the heading will have the country followed by the actual value. So we'll have country underscore Spain, country underscore Germany. Okay. So that is what this dummy functions will do. Now, after this, what will happen? My data will have the old name of the column, which is country. Plus, it will also have 2 new columns, which is country underscore Spain, because the first column I'm dropping using this parameter drop first. So this will be dropped. So I'll have country Spain. Then I have the new column country underscore Germany. So there are how many columns now? You started off with 1 column. Now, after the dummies, I have 3 columns. But because country and this country, Spain and country, Germany represent the same information, so I need to remove the old column name. So now I remove this old column name. So that means this column is gone. So now my new column will have only 2 values, which is country, Spain, and country, Germany. And this I have to do it for every dummy variable I have in every categorical variable I have in my data set. Clear? Is the flow clear?
Yes, sir, clear.
Okay, we'll take a break now, and after the break, we'll start with the model building process. We'll build the model, we'll do the prediction, and with different cutoffs, we'll see the performance of the model. So we'll meet in about 15 minutes. Okay, have you all completed till this point? Please confirm.
Yes, sir.
Okay, fine. So now let us go to the model building part. So once again, we will write functions to build the model, get the prediction and convert the predictions into classes. So we have train S, train X, test X, train Y, test Y equals train underscore test underscore split. So here the data is, okay, so we'll actually write a function because we will be building multiple models. So you don't have to keep writing the same thing again and again. So you can just create a function called split data. In fact, we have already written this function, if you remember, in the linear regression. So take the same function, what we wrote in the linear regression. You don't have to repeat it. Okay, and then train X, test X, train Y, test Y. So here instead of concrete, it is going to be churn underscore copy. And the Y variable that you have to pass. So here the Y variable is going to be churn. And now let us run this, and there you go. So quickly print the shape. So train X equals train Y equals test X equals and test Y equals dot format. Okay, so in the train data, there are 7,000 records. And in the train Y, there are 7,000 records. In the train X, there are 3,000 records and 9 features. And test Y, there are 3,000 records. So if you look at the train X dot columns, you will see that it has credit score, age, tenure, balance, active, salary, country, Germany, country, Spain, and gender underscore male. So the Y variable has been removed. Okay, clear? Please confirm if you have done till this, then I'll go to the next part.
Done.
Okay. Now I'll write the next function. Function to build the logistic regression model. So def build model. So train X and train Y. So in the build model, I'm going to build the logit function or the logit model. So model equals SM. SM is the short form, that is the alias for this one. Stats models.api. So this one. So SM dot logit train Y train X dot fit. Now I can do all these things in a single function itself, but I want to split it up into different parts so that we can analyze each part. And then as an exercise, you can convert them into a single function. Okay. So for the time being, I'm only going to print the summary and return the model. So print model.summary and then return the model. Okay. So once you are done with your first model, you want to build your second model, you can simply call this build model function with the new set of train X and train Y data. So let me call this model as M1. So the data is train X and train Y. And stats model, it says is not defined. And let me see here. Okay. Okay. And this actually should be summary and within brackets. That's why it is not printing the summary. So let me just do this again. And now you see it is printing the summary of the logistic regression model.
Sir, actually I'm getting an error.
Hmm?
Ndog must be in unit interval.
Can you share the screen?
Yes, sir, I'll.
Can you maximize the screen, please? Let me look at the. Okay, can you show me the split function? One second. Okay, the logit function in line number 62, it should be train Y comma train X. It's Y comma X. No, not here. In the logit function. Now it is okay.
Yes, sir, yes.
What about the others? Have you all finished writing this function? Are you able to see the summary? Yes, no?
No, sir. Wait.
Okay. Okay, finish it and just let me know. Then we can proceed. Okay, fine. Now, what is the next step? We have built the model. We have summarized the model. Now, I'm sure that you all know how to read the summary of a linear and logistic regression. So if you look at the coefficients are the log odds. So for credit score, you're getting minus 0.0042. Age, it is 0.05. Tenure, it is minus 0.05. Balance, it is very less. Active, it is minus 1.17. Salary, again, it's a very small number. So these are the log odds. So what it means is, if I take, let me just write it down. So the interpretation of the logistic regression output is slightly different compared to the linear regression output. Now, what is the meaning of this number minus 0.0042? Okay, it is number one, the B1 value, which is fine. But how do you interpret this value? It means that keeping all the other features constant. That means if I take all these features as 0 and have only the credit score. Now, what is my Y variable? Y variable is churn. Okay. So it means that keeping all the other variables constant, the log odds of a customer churning taking credit score as the feature. Okay, the log odds of a customer churning taking credit score as a feature is how much? Minus 0.0042. So what are the odds? Therefore, odds of a customer churning taking the credit score as a feature equals the anti-log of minus 0.0042. Now, if you calculate this number, you will get some value here. So that is the odd of a customer churning using just credit score as the feature. That is how you interpret this result. Clear? Now look at the Z scores. So credit score is 20.44. So that means it is highly significant. P-value, you can see it is less than 0.05. So I can say credit score definitely is an important factor to determine churn. So similarly, you can do it for the other features as well. So next we'll see how to do the cross validation before doing the predictions. So we will again take a little bit of this function from linear regression. So it won't be the exact thing, but a lot of these code are similar. So here it is going to be train X and train Y. Function name is do k-fold cross validation. And I'm going to take the default value of k as 5. Now, first thing that I need to change is it is not MSE. So it is going to be accuracy. Because we are dealing with a classification problem here. So this is going to be cross validation accuracy. The array will remain the same. X is train X dot values and Y is train Y dot values. So no change in this. So false equals 5. So there is no change in this one also. Now the only change that we need to do is inside the function. Model equals okay. Now before that, I need to add the libraries, which I don't think I have added here. Yeah. So just add the 3 libraries for. So from sklearn dot model selection. So here you can put k-fold. Then from sklearn dot linear model import logistic regression and accuracy score I have already taken here from sklearn.metrics. So that is taken care. So just include these 2 libraries. Now let us come down. So first is we'll build the model on logistic regression. So because we are doing a binary class, so the flag has to be given as bilinear. And then model.fit. Cross validation, train X, cross validation, train Y. Okay, and now predicted values equals model dot predict cross validation SX. Okay, and now cross validation underscore accuracy dot append accuracy score. What is the actual data, which is CV underscore test Y, and predicted data pred underscore values. And then you can return CV underscore accuracy and then return, fine, this is fine. And you can also return sum of CV underscore accuracy divided by K. Okay, so the first return value is all the accuracies for every cross validation. And the second return value is the average accuracy or the mean accuracy. Is this code clear to everyone? So let us do the cross validation and see what is the mean accuracy. So in case if I don't want to return the first set of parameters, which is the accuracy for all the sets, I can give an underscore and then give CV accuracy 1, CV accuracy equals do K fold cross validation train X and train Y. Made a mistake here. Instead of lib, I wrote bilinear. It is lib linear. So now you can print cross validation accuracy equals format cross validation accuracy. So it is 79.51%. Okay, is this code clear to everyone? Any question?
सर क्रॉस वैलिडेशन का फिर से बता सकते हैं?
क्रॉस वैलिडेशन पे क्या होता है? 5-fold क्रॉस वैलिडेशन या whatever क्रॉस वैलिडेशन, it is going to perform the training and testing on the training data itself. And then it is going to find out what is the performance of the model on the data on which it was trained. और उसके बाद we will compare the performance of the model on the data on which it was trained versus unseen data. So that is why we are training the data on the training data itself and testing the data on the same training data. Okay. So because this is a logistic regression, so we want to find what is the overall accuracy of the model and not the mean square error, which we have used in linear regression.
Okay, sir.
So based on the cross-validation results, we have found out that the overall accuracy of all the 5 models is 79.5%. Now, if you want you can say fold-wise accuracy. So fold accuracy. So if you print the value for fold accuracy, you will see, since there are 5 values for K, so first fold accuracy was 80%, second fold 80%, third fold 78%, fourth fold was 80%, fifth fold was 81%. So overall, the accuracy is 79.5%. Is this part clear to everyone? Yes, no?
Sir, actually, I think I cannot get the cross validation concept itself. The code.
The code you're not able to understand.
No. So the concept.
Okay. One second, I'll see the idea of a cross. One second, let me share my other screen. Is the whiteboard visible to everyone?
Yes, sir.
Okay. Now, what is the idea behind doing a cross validation? Now in cross validation, okay, the overall process is you have the data, you perform the EDA, and then you split the data. Now, after you split the data has two portions. One is the train data, and the other is the test data. Now, using the train data, we build the model. Okay, now at this stage, generally what we do is we take the model and do the prediction on the test data. This is also a kind of cross-validation. Okay. Now, instead of directly applying this model on the test data, we take a pause and we want to find out how this model behaves on the same data on which it was trained. Are you getting this point?
Yes, sir.
Okay, it is kind of a validation that I'm doing, that after the model gets trained on a data, if it has to do the prediction on the same data, how will its performance be? So this process is called cross-validation. So after my model gets built, I'm going to take this model and do the prediction on the same data itself, which is the trained data. So this trained data now gets split into two parts. Okay, so this is where we do the k-fold cross-validation. So K means, so let's assume that my trained data has 100 records and my testing data has, let's say, 15 records. And I'm doing a k-fold cross-validation where the value of K is 5. Okay, now because the model is going to be tested on the same data, that means the testing is done on these 100. Okay, so this 100 now gets split into 5 parts because I'm taking a 5-fold cross-validation. So the 100 gets split into 5 parts, where part 1 has 20 records, part 2 has 20, part 3 has 20, part 4 has 20, part 5 has 20. This is part 1, this is part 2, part 3, part 4, part 5, and total count is 100, which is the training count. Clear?
Yes, sir.
Okay. Now, once this is done, now I'm going to perform the k-fold cross-validation. So how this happens? This 100 records that I have in my training data get split into 2 parts. So 4 parts become training data and 1 part becomes testing data. Okay. So out of these 5 parts, 4 parts become training and 1 part becomes testing. So if you look at this combination, I have P1, P2, P3, P4, P5. So 4 parts out of these 5 will become the training data. So in my first iteration, if I take P1, P2, P3, and P4 to be my training data, so P5 will be the testing data. Okay, so this is what the split function is doing. If you look at the code, when you split, it splits into 2 parts, training X, training Y, and testing X and testing Y. So it is going to do the split. Now in the second combination, I'll have P1, P2, P3, P5. Then I'll have P4. Then in the next combination, I'll have P1, P2, P4, P5. Then I'll have P3. Then in the next iteration, I'll have P1, P3, P4, P5. Then I'll have P2. Then I'll have P2, P3, P4, P5. Then I'll have P1. Okay, so there will be 5 iterations. Iteration 1, iteration 2, iteration 3, iteration 4, iteration 5. So in the first iteration, my model will be built on these 4 parts. So I'll have model M1. The prediction will be done on the 5th part, which is P5. And from this, I'll have the accuracy, which is, let's say, A1. Okay, so if you look at the result, I have returned 2 values. One is the fold-wise accuracy, and one is the mean accuracy. So fold-wise accuracy is A1, A2, A3, A4, A5, and the mean accuracy is mean of all the accuracies. So next iteration, this is my training data. My model is built. The prediction is done. And then I get the accuracy, let's say A2. So this keeps happening till the last set, A5. Now I get a mean accuracy. So A bar equals sigma A upon 5. Is this clear now?
Yes, got it.
So now if you correlate, so here the for loop will be done based on how many folds I have. So if I take k equals 5, so I'll have 5 times the for loop will be executed, 1 for each training set and testing set. So how many accuracies will I get? A1 to A5. So that is what I'm getting here, which is the CV underscore accuracy. And this is the average accuracy. Have you all finished? Have you all copied? And are you able to execute this code?
So I'm getting the error.
Share your screen.
Yes.
It is liblinear. I think there is a spelling mistake. Liblinear, not Libby. L-I-B.
L-I.
You have put Libby.
Okay.
Remove the I after the B.
K is not defined.
K is not defined. Whereas it is not capital K, it is small k.
Where, sir?
Last line in the return, you have put capital K, and in the parameter you have given small k.
Small K. Okay, sir.
Okay, so now that we have done the accuracy using the cross validation, and we are getting the accuracy score as 79.5. Now let us do the actual predictions. Actual means the test predictions. So we will write functions again instead of doing it each time. So we'll write a function to find out what is the predictions and converting the results into classes 0 and 1, draw the confusion matrix, classification report, and the ROC curve. So let's do the prediction using the model, then using the test X. And then we'll take something called as the cutoff. So if you remember cutoff, the default cutoff we'll take is 0.5, and depending upon the results, we can change the cutoff so that we get a better accuracy. So let's call this P1. So P1 equals model.predict on the test data. Okay, now we also need one more parameter here, which is test Y. Because for the confusion matrix, I need the actual Y and the predicted Y. So I have the predicted Y here. I also need the test Y. So predictions on the test data. So that is P1. Now, can anyone tell me what is going to be the value of these predictions? When I use the predictions, they are the probabilities. Okay, P1 will contain a list of probabilities. So P1 will contain a list of probabilities that need to be converted to classes 0 and 1. This is done using the cutoff value. Clear? So first I'll make a copy of the predictions because I want to send back both the probability predictions and the class predictions to the calling function. So make a copy of the predictions. So we can call this as P equals P1 dot copy. Now I want to convert the value of P equals 0 and P equals 1 based on conditions. Now, what are those conditions? So wherever I have the P value less than cutoff, those values will be classified as class 0. And wherever I have the value P, which is greater than the cutoff, that will be classified as class 1.
So cutoff only depend upon accuracy, na?
Cutoff values are that will be determined by you. Okay. So I'm defaulting it to 0.5, which is the center point. So based on this cutoff, now you can decide whether the cutoff is on the higher side or on the lower side. Then you can change it accordingly. Now I am not including the confusion matrix in this, because if I have to separately publish the confusion matrix, I can simply run the function. So in this function, I'll only do the prediction. So actually, I don't want this test y parameter also here. I'll just do the prediction and return the probabilities and the classes. Okay, so now let us test it out. So predict on test data. So here the first parameter is the predictions or the probabilities, I'll say. So probabilities, comma, prediction y equals predict. Now look at the sequence P1. P1 is model.predict, which is going to give you probabilities. So I'm returning P1. So probabilities will be as P1 and capital P will be the actual predictions or the classes. So which is spread y. So the first parameter is what is the model? So model I have given the value as M1. And then the test X is going to be test X. And I have given the cutoff as 0.5. So let me take the the cutoff as it is. So it's going to be test X. Okay, so now my predictions have happened. Now, if you see pred y, okay, so these are the predictions. Now, if you notice, it is actually predicting the numbers as float values. So which I have to change it into an integer type. Okay, if you notice here, it is float numbers. So here you can put return as type integers. Okay, you cannot have a y value as a float value. So just make that change. Now it should return the integers. Just check it out. There you go. Okay, so now the numbers are in the right form. And if you look at the value for P1s, they will contain the probability values. Sorry, probs. Okay, so these are the probability values. Is this clear to everyone? Any questions, any doubts? Are you able to execute this code? Please confirm. Okay. So my predictions are done. Now evaluation of this model. So in fact, I can do this all in a single function, but I want to do it step by step. So as a practice, you can go through this again and put all these things in a single function. So the next step is model evaluation. So the three things that I have to write for the evaluation is number one, confusion matrix. So first is model accuracy. Second one is confusion matrix. Third one is classification report. And the fourth one is AUC and ROC. Okay, so all these things I can do it in the same function. So you can create a function called as, let's say, CM, confusion matrix. So this will take two values. What is the actual data and what is the predicted data? And I don't want this to be in capitals. You can put small cm. So first thing is print model accuracy equals dot format accuracy score actual comma predicted. So first is model accuracy, then print, then the confusion matrix. Now for the confusion matrix, I'm not going to use the confusion matrix library which is available because that does not give me a very good output. So instead, I'm going to use the cross tab functionality. Is this clear to everyone? The first two lines? Hello?
Yes, sir.
Okay, the third one is classification report. So print classification report, actual and predicted. Okay, and the last one that we have to print is the ROC/AUC. Now for the ROC and AUC, we have to import one library called metrics. I don't think I have done that. Yes, it is missing. So here it is going to be from sklearn. I have to import this library called metrics. And here you can write for ROC and AUC. Now ROC and AUC, it is going to take the two parameters, true positive rate and the false positive rate. So false positive rate, true positive rate. So this function returns three values and also the threshold. So since I'm not using the threshold value, so I'm just give a underscore here because I don't need that. So metrics. So from the metrics, I'm going to use the ROC curve function. Actual predicted. And then ROC AUC equals. So from this output, metrics dot, I have to find what is the AUC score. So let me not call this ROC. So I'll call this AUC. AUC is area under the curve. So AUC score equals metrics dot AUC, false positive rate and true positive rate. Clear?
Sir, threshold value not affect the ROC?
No, threshold value, it will affect the ROC. No? That is why we are taking the threshold in the predictions.
Okay.
Cutoff. So this threshold that you see, this is the return value of this function. That we don't need. So FPR is false positive rate. TPR is true positive rate. Okay, so and now I can plot the ROC curve. So PLT dot plot FPR, TPR. I want this to be in blue color. You can give the label as AUC. Just leave me title equals AUC plus STR of AUC score. And then label equals PLT dot legend, PLT dot title. ROC, AUC chart. Then PLT dot legend. So I'm going to put this in the lower right. Okay, so this is going to plot the best fit line. Sorry, the AUC. Now I also want the dummy model, which is the 50% model. So I'll put PLT dot plot. So from 0, 1 to 0, 1. So 0, 1, 0, 1. And I want the red line with a dot. So this is how you specify the, and then PLT dot X limit 0 to 1, because that is the probabilities, and PLT dot Y limit 0, 1. PLT dot X label positive rate. Minus false positive rate. Anything else that I want? I think that's all I have. Yes. So now let me compile this function and let's see if I'm able to get all these outputs. I'm not returning anything in this. Now confusion matrix. The actual data is test Y, and the predicted data, I'm already storing the predicted data here, which is spread Y. And now you can see so model accuracy is 80%. And I'm not getting the confusion matrix. Now, why is that? Because I have not given the print statement here. So this is going to be print and the cross tab. So let me make that change. And now you see model accuracy 80%, confusion matrix, and then classification report. And this is my ROC curve. So based on this output, can I say that I have a good model?
Yes, sir. Sir, in the given graph, the graph we have found, the dotted line is the predicted line, right?
No, the dotted line is the dummy model.
Okay.
Let me just plot it again. See the dotted line that you see, that is the 50% model.
Okay.
Or we call that as a dummy model.
Okay, yeah, you see, got it, sir.
So the one that is in blue, that is the predicted data.
Okay. Yes, sir. Got it.
So if I have to build a good model, my model has to be well above this red line. I actually gave the values wrong. True positive should be the y-axis. Sorry, just make that change. Y label should be true positives and X label should be 1 minus false positive bit. Yeah, this is fine. Okay, so here I can see in the output 82%, class 0, which is a negative class, is getting predicted 96% of the time. So that is evident here. Out of 2,365, there are 2,271 records getting predicted as 0. That means as customers not churning. Whereas customers who are churning is 635, out of which only 132 have been predicted correctly as churned. So 132 out of 635, which is 21%. So which is not a very good score according to the data. And this is expected because of the high imbalance that I have in my data. So how can we improve this? So go to this code and change the cutoff. So in the prediction, you try to give a different cutoff and see how the values are getting affected. So if I give cutoff equals, let's say 0.25. So will it make any difference? Now see. So 50%, I got an accuracy of 50%. That is the AUC of 50%. When I change the cutoff to 25%, I'm getting a AUC as 66.7%. And see how the confusion matrix has changed. From 21%, it has jumped to almost 3 times. And the negative class has reduced from 96% to 77%. So this is how you have to mix and match or weigh things so that you get the optimum or the best results. Is this clear to everyone? So I give you the class assignment. Do feature selection. And select the best features. And build a new model. So do this now and let me know that which is better, the feature selection model or the original model. So do this exercise. This should take around 20 minutes, maybe half an hour. So do this and let me know. Hello everyone. Are you doing this class assignment? Hello.
Actually, I'm not able to do. I'm not able to figure out which variables to drop for the.
From the summary, we have done that, isn't it? The linear regression, the same technique has to be applied here also.
Okay. Okay.
Okay, let me tell you one more technique. Feature selection. Number 2. So one way is you can use the technique of summary and then figure out the best features. The other technique that you can use is using the feature selection library. So if you look at the top, we have downloaded one, imported one library called f_classif. Okay, so this is a feature selection. So we'll use this method. So fs will use train x and train y. Now this is going to return us 2 values. What is the score? That is the feature score. And what is the p-value? What is train x? Okay, so you can see here the score that I get. So how many features are there? The number of scores will also be the same. And now create a data frame. To store the features, scores, and p-value. So I can say df underscore features equals pd dot data frame. So feature is going to be train x dot columns. Score is going to be score. And p-value is going to be p-value. Okay, so now if you look at the features data frame, you will see that every feature has been given a score along with the p-value. So higher the score or lower the p-value, more significant is that particular feature. So now if you want to sort it, so I'm just going to sort it by score. I have to give ascending equals false. So now you can see that according to the score I have sorted, so age becomes the most significant feature. Then I have country, Germany. Second, active is next, balance is next, gender, male is next, country. So credit score, tenure, and salary, they are at the bottom. they are features having which is less than 5. So I can probably remove or take one feature out of the data set and try building the models. Is this clear?
Yes. Yes, sir.
So higher the score, more significant is the feature. Yesh, can you share your screen?
Yes, sir.
I'm not able to view your screen.
Sir, just a second. My screen is lagging.
Okay. Key error score. Okay. Can you show me the data frame? Where have you created the data frame? Scroll up. I think the screen has frozen.
Sir, is it visible now?
No, I'm only seeing that error message. Check for duplicates.
Okay, I'll reshare. Hello.
Yes.
Sir, actually my computer froze. I am not able to do anything.
Okay, that error message means that you have not created that column called score. Just check the spelling.
Okay, sir, I'll check.
What about the others? Have you finished?
Yes, sir.
Okay. So that's all we have in today's session. So tomorrow also we have the session. So I want you to open the practice problem set that you have in your link and do that, and you can do the presentation, or you can just show me what you have done. Okay, so that will be the activity for tomorrow. Okay, any questions from anyone?
Sir, revise करेंगे क्या फिर से जो आज हो गया?
हाँ, we'll do that tomorrow. Okay.
Okay.
Sir, the error is solved.
Solved? Okay.
Yes.
ठीक है, तो tomorrow we'll do the review, and we will also take the problem statement that you have in your LMS, and you can start doing that. Okay.
Okay. Sir, tomorrow class timing?
Same, 9 to 1.
Okay, sir.
Okay, so thank you everyone. See you all tomorrow then. Bye.
Thank you.